When we want to find area between two curves, I realize these curves are straight lines, we look at the concept of dividing these up into rectangles. Now, there's two formulas. You can keep it in terms of x. When you keep it in terms of x, we look at subtracting the bottom function from the top function. And in this case, I'm going to call the top one y is equal to 2x, and the bottom one y is equal to x. And we also have x is equal to 2 as our vertical line. Now that means that if we're looking along the y-axis, that this is 2 and this would be 4 if you substitute that 2 into each of those equations. And then this is 0. The way we set this up is imagine that we're cutting into that region by cutting down, and so the first one we hit is y is equal to 2x. This is the top. This one's the bottom. And the formula that we use for this is our equation from a to b of f of x minus g of x. Fix that. dx. Alright, so let's move to the next screen and we will solve the problem, and this will give us our area. So let's plug everything in. So we're using, everything is in terms of x at this point, so 0 to 2. And our top function was 2x, and we're going to subtract x and then integrate that. So before you integrate, we are going to reduce, so that just gives us an x dx, and that gives us x squared over 2 from 0 to 2. And we're going to substitute in, and 2 squared is 4, x 0 squared is 0, and that just gives us our units squared. Now, not all functions are oriented a top and bottom. Sometimes we have some that are oriented more right minus left. So let's take a look at that one. Now for this one, if we were doing the area and we were going to do top minus bottom, well, along this line right here, the top splits. So it starts out with the top function being y is equal to 2x right here, but then it changes right here to y is equal to 2. In this situation, it makes more sense for us to, instead of cutting from top to bottom, cut from right to left and make it right minus left. Now a right minus left is in terms of y. So you use the variable of the axis that you're pointing towards. So that means we're going to have to solve y is equal to 2x for x. So x is equal to 1/2 y. Okay, so let's put this in. Well, if y is equal to 2 right here, but we're also going to use y values instead of x values. So instead of 0 and 4 like we used before, 0 to 2 like we used before, we look along the y-axis for our values. So here's our formula for this. So in terms of y, it's the integral from c to d of f of y minus g of y dy. And this is right function, or right equation, minus left. Okay, so what we're going to have when we plug all of this in is 0 to 2. Our right side is x is equal to y. Going to subtract the left side function, which is 1/2 y dy. And we'll go to the next screen. And so we have 0 to 2, once we simplify that, 1/2 y dy. And at this point we take the integral. So when you raise your exponent, it's going to become y squared, and when you divide 1/2 by 2, it gives you a 4, so 0 to 2. And then we're going to substitute in, so 2 squared is 4 over 4 minus 0, and this one is 1 unit squared. And that is area between two curves.